In this video here, we're going to take a look at the centre of mass. So up to now, whilst looking at problems involving moments, we have only considered problems involving uniform rods. And what this tells us then, if we have a uniform rod, is that the centre of mass for the rod is at the midpoint. So for this video then, we're now going to consider problems where we have a non-uniform rod, where the centre of mass is not necessarily at the centre of the rod. And we may have to now consider the moment due to the weight of a non-uniform rod, or we might have to find the position of its centre of mass. So in terms of an introduction here to the centre of mass, we don't really need too much more here. There's no new notation, no new formula or anything like that. Just, further exploring this concept of moments and building on that by looking at the centre of mass here for a non-uniform rod. So there we have it. That is our introduction here to the centre of mass. Let's just take a look then at one practice question here. So let's have a go then at this one practice question here for the centre of mass. So for this question then, as we can see here, right, we have a non-uniform rod AB, which is 5 meters long and has a weight of 30 newtons. We're told that it's in a horizontal position on two supports labelled as C and D, where AC is equal to 0.5 meters and AD is equal to 4 meters. We're then told that the magnitude of the reaction at C is 2 times the magnitude of the reaction at D. The question then wants us to find the distance of the centre of mass of the rod from A here. So as we can see then, right, we don't have a diagram for this question. So the first thing that we're going to quickly do here is just draw our own diagram. Okay, now it doesn't have to be perfect, by the way. My art skills do leave much to be desired, but I'll give it a go. So let's say that this is my non-uniform rod, then AB. So I've got A here and B at the end. We have two supports labelled as C and D here. So let's say that this is C here. And then we also have D, like so. What else do we have here, right? We also have these distances that we're given. So from A to C here, that's 0.5 meters. So this distance here is 0.5 meters. And we're also told that AD is equal to 4 meters. So from A to D here, that's 4 meters. So in that case then, we can see that from C to D, that must be 3.5 meters. Okay. And if from A to D then is 4 meters and the total length is 5 meters, what that means then is this length here must be 1 meter. Okay. Like so. Now we do also have these two supports here, right? And at the supports then we will have the reactions. I've got a reaction at C here. We also have a reaction at D. Okay, now if the magnitude of the reaction at C is 2 times the magnitude of the reaction at D, if the reaction at D then is simply given as R, so that would be R newtons here, then the magnitude of the reaction at at C here is going to be double that. So if the magnitude of the reaction at D is R, this would be 2R. Okay. So we get 2R newtons there, like so. And then don't forget, we also have the weight of the non-uniform rod here. Now, because it's a non-uniform rod, what that tells us then is the center of mass here will not act at the midpoint. Okay, so let's just say it's somewhere around here, right? So not at the middle, a little bit further to the left here. Okay. And the weight then is 30 newtons. So we've got 30 newtons there, like so. Okay. So what we want to find then is this distance here, right? So from A to the center of mass here, that's what we want to find. So let's label that then as X here. Okay, so X meters here, and that's what we want to find then for this question here. So we've got our diagram, and I think we should have just about enough now to answer this question. So to get us started here, then let's just begin by resolving vertically. So if we resolve vertically here, right, like so, we know that forces acting upwards here are equal to forces acting downwards. So for my forces acting upwards here, we've got 2R plus R then. So that would give us 3R for the forces acting upwards. And that will be equal to forces acting downwards, which is just this one force here of 30. So we get 3R equals 30 here. And then if we just want R right, just divide both sides by 3. We find that R is equal to 10 newtons there. Okay, so a good starting point there. We find the value of R. So now what we're going to do then is take moments here. Okay. So I'm going to take moments about A here. Okay. And what I need then is the clockwise moments and the anti-clockwise moments. So for the clockwise moments here, it will actually just be the one force then, right? Because imagine you hold the rod at A. If I push downwards, that would produce a clockwise moment. The other two forces produce anti-clockwise moments. Okay, so nice and straightforward here for the clockwise moment, right? My perpendicular distance is x meters here, so it's just going to be x times by the magnitude of the force, which is 30. I get 30x there. Nice and straightforward. And now for the anti-clockwise moments here. So as we said then, that relates to these two forces here. So in that case then, I've got the magnitude of the force, that's 2r, but we know that r is equal to 10 here. So I get 20 times by the perpendicular distance, which is a half. So we have 20 times by a half there, which would obviously give us 10, but we'll simplify that in a moment. Plus, so doing the same here then for this force here. So the magnitude of the force is r, so that's 10 times by the perpendicular distance here, which would be 4, right? So 3.5, and then another half here, or just the distance AD. You know, they're both the same thing, either's fine. We get 10 times by 4, which would give us 40. So if we simplify that here then, I get 10 plus 40, so that gives us 50 there. Okay, like so. So clockwise moments are equal to anti-clockwise moments. So clockwise is equal, anti-clockwise is equal to clockwise. Either's fine, don't matter which way you kind of describe that. So in that case then, what I get here is 30x is equal to 50 here, like so. So obviously we want to find the value of x here, right? That's this distance then of the center of mass of the rod from A. So just divide both sides by 30. In that case then, x is equal to 50 over 30, which we can simplify to give us 5 over 3. That would be 5 over 3 meters here, right? But let's just give it to 3 significant figures here. So we could give this as 1.67 meters here. So in that case then, the center of mass, is 1.67 meters away from A. So 1.67 meters away from A. Okay, and there we have it. So that's all we need then. We find the distance there of the center of mass of the rod from A. And there we have it. So that gives us the solution there. This one practice question. And that brings us to the end then of this video here on the center of mass.